Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list and the basic operations. And today we'll do the next question or last question from this pattern, which is odd even linked list. So let's read the problem statement. It says we'll be given a linked list 1, 2, 3, 4, 5, and we have to connect the linked list in the alternative order such that all the odd indices, now you will say linked list do not have indices. Okay, just for the reference it is saying ki all the nodes which are occurring at the odd indices needs to be connected first and then the even nodes. Along with that, if you see 1, yes, connected to 3, yes, connected to 5, yes. And after that, like where 5 ends, now you have to connect the head of the whole even linked list. So what is the head of the even linked list? Definitely 2. So after 5 we have to connect 2. So this is our task, and we have to return the head, means 1, after the reconnection, so that the whole linked list which we have changed into odd first and then even first will get returned. Okay, so now let's see the constraint. The constraint says the number of linked list, like number of nodes, will be from 0 to 10 power 4. Okay, 10 power 4. Why? Because if you give the n square solution, means 10 power 4 will become 10 power 8, and beyond 10 power 8 the code might give us TLE. How? Because we have already discussed everything in detail in our previous video. I'll add the link somewhere here. The video name is time and space complexity. If you are still confused how to decide the pattern and approach based on the constraint, then definitely I'll recommend you all to go and watch that video first. Okay, so now let's come here. As the question says, we will be having different values 1, 2, 3, 4, 5. Remember, we do not need to connect on the basis of values but on indices. So value might be 0, 3, 5, 1, 4. Okay, but still you have to connect this together. So it will be 0, 5, 4, and then 3 and 1. So 3 and 1. Correct? So this is how we have to return. Okay, so what is the first approach which comes to our mind? Like forget about the optimized approach. Let's think for the very layman and brute force approach. So at initial phase, how you can think is ki why not to do one thing? Let's iterate in the whole linked list, okay, and save in an array. So let's say 1, 2, 3, 4, 5. Correct? Now array though has indices. So now start your I pointer, and if your I pointer is like it is 0, right? So 0 means we have to consider it as the odd node of the linked list, correct? So everywhere I modulo 2 is equal to 0, means this one, then 3, then 5. So we have to connect them. So we will make 2 linked lists. Let's name it even and let's name it odd. If I is even, so we will connect this in even, and if I is odd, then we'll connect this in odd, correct? So this is even as per us, but as per the linked list, the even is odd and the odd is even. I hope you get this. So now 1, 3 and 5 once connected. So at the end of this 5, which is stored in even, so even dot next, we have to connect this 2. So 2 as a head we have to save somewhere else, okay? But in this approach, first though we will make an array and to store every value, so that will take O of n extra space complexity, and we will make new linked list n by 2 for even and n by 2 for odd. So together O of n. So O of n for array and extra O of n. So in together O of 2n extra space complexity. Can we think for better approach here? But how? Okay. So we know that we cannot touch head, correct? Otherwise we will lose the whole linked list itself. Okay, so we always prefer to make different aliases. Let's say current 1, or we have to consider this odd, right? So let's name it odd. Okay, this is odd. So what do you think? We have to connect this with this, correct? So we can think ki why not to write odd dot next, which is currently 2, I want to connect to 3. So odd dot next dot next. Okay, this might be correct, but we have to keep track of 2 also. If you will directly connect to this, so you might lose 2 forever. So we have to save it somewhere, correct? Yes. So let's name it even to save it. Okay. So instead of writing this now, we will write, like, let's initialize odd is nothing but head and even is nothing but head dot next. But before writing this, please check कि your head and head dot next should be available. It should not be like कि you have only one node in the whole linked list. Then it does not make sense, you know. Also, if you have 0 nodes in the linked list, it does not make sense. So definitely odd and even are there, and now we can, like, for the to length also we cannot do that. I hope you get it, because this is already odd and it is already connected to the even position. Okay, so when the length is greater, so length basically means if you have head and if you have head dot next, so now you can think of moving forward to reconnect. Okay, so now you have renamed as odd and even. Now what do you think? This odd next should get connected to 3, and where is this 3? Can I say even dot next? Yes. So what we will write? We will write odd dot next is equal to even dot next. Very simple. So now how will it look like? Let's make it. Odd means 1 dot next. Now 1 is connected to 3. Now if you're thinking we lost 2, no, we haven't lost it. Why? Because like even pointer is still storing this address of 2. Correct? So now 1 is connected to 3 and now 3, 4, 5. It looks like this. And 2 is still connected to 3. Okay? So this is odd, this is even. Now one more thing. Odd 1 has been connected to 3. So now do you think we still have to wait at the same location or we should move our odd forward? Definitely. Why? Because earlier we were here to connect our next. Now it is already connected to 3. So now, like, it does not make sense at waiting at the very first location. Correct? Now as it has been connected, so let's move forward. So now we will write odd is equal to odd dot next. Now as we have already connected our odd dot next to 3, so when we will write this odd is equal to odd dot next, so now 1 will get connected to, like 1 will get moved to 3, not at 2, because now this does not exist anymore. Okay, so now where is my odd? Can I say my odd is pointing to 3? Yes. Done. Now what about even? Even is pointing to currently 2, and what I want to connect 2 with 2 dot next should get connected to what node? Can I say 4? And where is this 4 saved? Can I say odd dot next? Yes. Very good. So what we will write? Even dot next is equal to odd dot next. Now what will happen? This will get removed and 2 is connected to 4. Again the same process as we are done with this node. So let's move our even to 4. So what we'll write? Even is equal to even dot next. Done? Yes. So now what will happen? This will get moved to 4. Again, what do you think? We should, now what is the task? 3 should get connected to 5. Means 3 get connected to even dot next. Means odd is equal to even dot next. Have we already written this somewhere? Yes. Odd dot next is equals to even dot next. Correct? Now again after that we'll move our odd at 5. Okay, at 5. So let's move it. So here odd will point. Now again after this even dot next, which is 4, now I want to connect this with odd dot next. Means 4 will have null. Correct? So 4 dot next will have null now. Okay, yes, and 3 is connected to 5. Correct? Now even is equal to even dot next. So earlier even is pointing to what? 4. So now even will point to null. Now do you think we should move forward or we should stop now? Obviously we should stop. So what made this stop? Even or odd? Even. Okay. So in this case, as the length was odd, means 5, so even has made us stop. Now think about ki what if we have even length? Means 5 was not there. Just remove it. Okay, 5 is not there, only till 4. So if 5 was not there, just let's go one more position back. Okay, so 3 was connected to this and odd was here and even, just a second, and this was connected to null and even was pointing to what? Where? Here. Okay, so in the previous one where our length was odd, we saw ki even became null, so we wanted to stop. Now in this case, odd is here and even is at 4. Means 1 is connected to 3, yes, yes, and 2 is connected to 4. Correct? So now, do you think we should iterate further? Means 3 needs to be connected to something else, or we should stop? If you are thinking 3 needs to connect with 2, that to we write after coming out of this function. Okay? But as of now, if the length is even, do you think 3 needs to get connected with any odd indices values? No. Similarly, do you think 4 needs to be connected with any even indices value? No. So can I say I have to stop? So with what condition? Even is null? No. So what? Even dot next is null. So I can say if even is null or even dot next is null, stop. Otherwise, keep repeating this same process. So we will add this in a while loop. Very good. So we'll add while our even is not null, yes, or else even dot next is not null. We'll keep on repeating the same process, and that's it. Now, after coming outside, like, can we say ki we have to return this as it is? Because see, your odd is at 3, your even is at 4. So you should have kept a track of this, which is already head. Okay, you can say return head. But if you will return head as of now, you will get 1, 3 and 4 and null. Where is 2? You need to connect 3 with 2, right? Yes. So you should have kept a track of the even head also. Okay. So let's say even head is equal to head dot next. Okay. So this even value, like this even pointer, so you will move to disconnect and reconnect back with the even nodes. But this even head, you will keep a track so that at the end of the odd node, you can connect that head of the even. Okay. So after coming out of this, you have to write odd, which is 3, dot next. Please connect yourself to even node or even head, sorry, even head, and that's it. And now you can return the head, because now head is 1, correct, and now 3 has been connected to where? 2. So if you see this, it's now 1, 3, 2, 4 and null. That's it. Okay. So what's the time complexity for this, or space complexity? We have used 2 different pointers and we are running this while loop until the even become null or its next become null. Means we are iterating our even node from head pointer till last. So it's O of n. Yes. And what about space? We are just using 2 different variables, so it's constant. Correct? So hence it is the most optimized approach. So let's write the code for this. Okay. So let's write the base case ki if our head is null or our head dot next is null. So in that case, we don't need to do anything. We will return our head as it is. Done. And now we have to make a list node. Let's say odd. Odd will start from head. List node even. Even will start from, sorry, list node even will start from head dot next. And from the same location, we have to start list node, let's say even head, so that at the end we can connect our odd last node to the evens first node. Correct? So even head is equal to even. Now we'll write while our even is not is equal to null. Along with that, we will add AND operator. Why? Because suppose your even is null, so OR will still check even dot next. So null dot next will give you null pointer exception. Okay. So we have to check with AND operator. So while this is not null, we have to do odd dot next. It needs to be connected with even dot next. Correct? And after that, we have to move our odd at odd dot next. That's it. Now similarly, even dot next, we want to connect with odd dot next, and then even needs to moved ahead. Then now after coming outside, we have to connect the last node of the odd with even head, which we already saved earlier. That's it, and we will return head. And done. Now let's run the code. Now let's try to submit this. So as you can see, it has been submitted with the 100% accuracy also. The reason being, it is like the most optimized code with O of n time complexity and O of 1 space complexity. So this was code in Java. Here is the code in C++ if you are from C++ background with a similar approach. And here is the code in Python if you are from Python background. So I hope you understood. If yes, then definitely we can go in the sheet and we can mark the last question from this pattern as done. So I hope you will solve along with me. And if you have any doubt, do let me know in the comment section. The sheet link and my social media link will be there in the description. If you have any doubt, please feel free to reach out to me for any kind of guidance. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.